Okay, this is the first mass spectra with which we will try to predict the possible structures for the molecule that may have caused this spectra. Now, structural elucidation is kind of like whodunit. It's a bit of mystery where you have to use spectra to figure out which molecule or what molecule actually caused the spectra. So, the first thing you do is list the peaks occurring in your mass spectra. For instance, here we have a peak at 114, another peak at 71, another peak at 58, and another peak at 43. Second, identify the MZ value for the molecular ion. This tends to be the peak with the highest MZ value. We know that peak at 114 is the total molecular mass, or in other words, the molecular ion's molecular mass. And as a result, peaks with MZ values less than 114 represent the molecular masses of the fragments that make up the molecular ion. Now, before using mass spectra to predict the structure of the substance that caused it, it is very useful to have on hand a list of molecular masses of fragments from different organic compounds. For instance, a peak with an MZ value of 43 could have been caused by a positively charged 2-carbon aldehyde fragment, a positively charged 2-carbon ketone fragment, or a positively charged 3-carbon alkyl fragment. It is important to note that straight and branched chains will have the same molecular mass and therefore the same MZ value. Now that we have the MZ values for the peaks occurring in the spectra, we can now list the possible molecular structures for the fragment that might have caused each peak. For instance, the peak at 71 may have been caused by a positively charged butanone fragment, butanol fragment, or pentyl fragment. The peak at 58 could have been caused by, I'm not sure. This MZ value does not seem to match any of the structures in our database, and as a result, we have to keep this value in the back of our head, but we do not need to comment or justify this peak. The peak at 43 could have been caused by a positively charged ethanone fragment, ethanol fragment, or propyl fragment. On the right of the slide are the structures for the fragments we proposed. These fragments can be joined together and give us an idea of the full structure of the molecular ion. So now we have to find a combination of fragments that can add up to 114. The only fragments we have to play around with are 71 and 43. So the molecule that could have caused the spectra could either be octane, or heptanal, or heptan-2-one, heptanal, hexane 1,6-dial, or 5-oxohexanal, or heptan-2-one, 5-oxohexanal, or hexane 2,5-dione. I actually found this spectra, and it belongs to heptan-2-one. Of course, the question is, how would you have known? It is important to know that mass spectra alone is not sufficient to exclusively identify the molecule that caused the spectra. In order to narrow down heptan-2-one from this list of other molecules, HNMR, CNMR, and even IR spectra would have evidence that could have been used to exclude many of the following molecules that were listed here. Unfortunately, HNMR and CNMR spectrophotometry will not be covered until year 13. Stay tuned for the next spectra.